last question we are looking at for today. The previous question we look at, question 4, was under acid, base, and salt. Now the next question, that's question 5, is under mole concept. Mole concept, specifically preparation of standard solutions. Preparation of standard solutions. Okay. So the question really says, Fig 1 is an illustration of a set of glassware used in the preparation of exactly 100 cm cube of 0.1 molar solution of sodium chloride in the laboratory. So you can underline the statement 100 cm cube of 1 molar solution of sodium chloride in the laboratory. Now it says, study the figure and the information below carefully and answer the questions that follow. So you have various apparatus or glasswares indicated in the diagram. And also, the question says the capacity of A is 100 cm cube. So if you look at the setup A, the glassware labeled as A, says the capacity or the total volume of the setup of the glassware A or the apparatus A is 100 cm cube. It says the setup B or the apparatus B contains distilled water. And then it says C contains weight amounts of sodium chloride. And then the last information there is that the molar mass of the sodium chloride is 58.5. Okay. Now, so the question A says, identify each of the glasswares A, B, C, and D. Identify each of the glasswares A, B, and C. Okay, so let's look at the solution to question A. We are supposed to identify the glasswares A, B, C, and D. Okay, so the glassware A, that is your volumetric flask. The B is your measuring cylinder. And then your C is beaker. And then your D is the stirring rod. Okay, so those are the apparatus indicated in the diagram. Now question B says, read and record the volume of distilled water in B. So it's stated in the preamble that the glassware B contains distilled water. Now the question is asking to read and record the value of the distilled water in B. Okay. So as usual, when a diagram is given and the values are given, you're supposed to read and record. You're supposed to determine the value of each of the smaller divisions. If you take the 100 and the 150, and you count the divisions between them, you realize that there are 10 divisions between them. So if you want the value of each division, it will be 150 minus 100 over 10. So 150 over 100, 150 minus 100 over the number of division between, which is 10. And that'll give you 50 on 10, which is equal to 5. So it means that each of the smaller divisions you are seeing there, the value is 5. Now, if you count from the diagram, you can see that the level of the water is pointing to the 9th division after the 100. The 9th division after the 100. So if you multiply the 9 by the 5, that will give you 45. And you add it to the 100, that will give you 145. So the volume of the distilled water in B is therefore equal to 145 centimeter cube. So that is the B. So that is 145 centimeter cube. Okay. Now question C. Question C says, determine the mass of sodium chloride in C. So if you read the preamble, it says C contains weight amount of sodium chloride. So the question is asking you to determine the mass of the sodium chloride in C. That was used for the preparation of the 1 molar solution of the sodium chloride. If you remember, when we were reading the question, I asked you to take note of the statement 100 cm cube of 1 molar solution of sodium chloride. That was what was prepared. So from that information, the 1 molar represents the molarity or concentration. Concentration, which is represented as C, is 1.0 molar. You should know that actually you have two types of concentration, molarity and then mass concentration. But the unit here is molar. And if the unit of concentration is in molar or mole per dm cube, then it represents molarity. So even though this concentration, this specifically molarity. And then you also given the volume that was prepared, that is 100 cm cube. So that's volume. cm cube. You know your volume should be in dm cube. So you convert the centimeter cube into dm cube. How do you do that? You divide it by 1,000. So if you divide this by 1,000, that will give you 0.1 dm cube. 0.1 dm cube. Okay, and then you go back to the information under the diagrams. It says the molar mass of NaCl is 58.5. So you have molar mass of the sodium chloride. Molar mass is represented as capital M. That's 58.5. Unit of molar mass is gram per mole. So 58.5 gram per mole. In fact, this has been simplified. In some cases, or in most cases, you would be expected to actually calculate the molar mass yourself. So in that case, they would have given you that Na is probably 23, and then Cl is 35.5. And then using this information, you calculate the molar mass of NaCl. So for instance, in your calculation, molar mass of NaCl here would have been equal to, we have 1 sodium, 1 Na, and then we also have 1 Cl, so 1 chlorine, and then you substitute the values given. So Na is 23, and then your Cl is 35.5, and if you add that, that'll give you 58.5 gram per mole. Okay, so instead of giving you the actual molar mass of the compound, they would have given you the atomic masses of the elements in there, and then using the atomic masses, you yourself, you calculate the molar mass. Okay, but in this case, it has been simplified for you. So this is just for you to recap what we did under mole concept if you have forgotten how to determine molar mass. And the question is asking us to determine the mass. So we are actually going to calculate for the mass. Calculate for the mass. So mass of N is here. The mass is represented as small m, question mark. That's what we are looking for. If you recall what we did under mole concept, we had two formulae for calculating molarity. That is C. C is equal to, when mole is given, your C is mole over volume. But in the case where mole is not given, a given mass, your C is equal to mass over the molar mass times volume. So if you look at these two formulae, this is the one that contains mass. So using this equation, you make the mass the subject. You make the mass, that is the small m, the subject. Okay. So we know that our C equals small m over big M times V. So if you make the small m the subject, that will be the C times the big M times the V. Okay. So we continue by substituting the values. We have the C giving us 1.0, so that is 1.0. The molar mass as 58.5, and the volume as 0.1. If you multiply this, that should give you 5.85 grams. Okay, so from here it implies that the mass of the sodium chloride in C is equal to 5.85 grams. 5.85 grams. Okay. Now we're going to look at the next question, that's question D. It says you describe how the 100 cm cube of the 1 molar solution of the sodium chloride is prepared using the materials provided. Okay, so this is just like preparation of standard solution. We've calculated the mass of the sodium chloride. That was weight. So all that you're supposed to do is what? You weigh this amount. So this amount that is going to weigh. How do you weigh it? You make use of the top unbalance, and then with the help of a spatula. After weighing the 5.85 grams of the sodium chloride, you transfer it into the beaker, and then you add a little distilled water. You stir for it to completely dissolve to form a solution, and then you transfer the solution in the beaker into the volumetric flask with the help of a funnel. And then you now can rinse the beaker and the stirring rod thoroughly with more distilled water, and then add it to the solution in the volumetric flask. And then using the wash bottle, you top up the solution in the volumetric flask to reach the 100 centimeter mark, the 100 centimeter cube mark. Okay, so that's the process involved in the preparation. You can see that some of the apparatus are mentioned in the description are actually not part of the diagram of the glasswares indicated in the diagram, but those ones are also used in the preparation. Okay, so let's put that down. Question D. So 1. So that's the first step. You weigh the 5.85 grams of the NaCl on the top and balance, or you can say weighing balance, with the help of a spatula. That's the second step. You transfer the weight So you transfer the weight NaCl into a clean dry beaker. And then the next thing is you add a little distilled water. And stir. Okay, so you add a little So you add a little distilled water and stir with a stirring rod to dissolve completely to form a solution. And the next step is to transfer the solution in the beaker into the volumetric flask. So that's 4. Transfer the solution in the beaker into the volumetric flask. With the help of a funnel. The next step is rinse the beaker and the stirring rod thoroughly with water, thoroughly with distilled water, and add it to the solution in the volumetric flask. The next step rinse the beaker and the stirring rod thoroughly with distilled water and add it to the solution in the volumetric flask. And then using a wash bottle, top up the solution in the volumetric flask to the 100 centimeter cube mark. And then the last step, stopper the volumetric flask and shake it gently to properly mix the solution. So that's the final step. You stop at the volumetric flask and shake it gently to properly mix the solution. So those are the steps involved in preparation of a standard solution, specifically 1 molar solution of 100 cm³ sodium chloride solution. Okay, so that is D. And there is a final question, that is the E. You are supposed to determine. We're going to look at the last question, that is the E. You are supposed to determine the appropriate volume of distilled water that will remain in B after the preparation. So if you remember from question B, we are asked to record the volume of distilled water in B, and now we recorded it as 145 centimeter cube, if you can recall, 145. And the question is asking that we should determine the approximate volume of distilled water that will remain in B after the preparation. And you know that in the process, you are preparing 100 cm³ of the sodium chloride solution, and that involves the distilled water you added to the weighed sodium chloride for it to dissolve, and then after that we rinse the beaker, we added it to the volumetric, and then we top it to 100 centimeter cube mark. It means that if the experiment or the preparation is carefully done and there was no spillage of the volume of distilled water in B, that means that out of the 145 cm³, it was 100 cm³ that was used to prepare the solution. So all you're supposed to do is you subtract the 100 cm³ from the initial volume, which is the 145, and that will give you the solution for E. So quickly, I'm going to clean the A and then I'll add the E. The E. So for question E, approximate volume of distilled water that will remain in B equal to 145 minus 100. All that is in cm³. So, and that will be equal to 45.0 cm³. Or you can simply put 45. Okay. So that is the approximate volume of distilled water that will remain in B. The original, the initial volume was 145. 100 cm3 was used. That was the volume of the solution that was prepared. So we just subtract the 100 cm3 that was used in preparation from the initial volume, which is the 145. So you get 145 minus 100, giving you 45 cm3. Giving us 45 cm3. Okay, so this brings us to the end of question 5. And for that matter, the end of today's session. I hope you've well understood the questions that we went through today. If you still have any problems or difficulties, challenges, you can contact me later for further explanations. Please, as we have been saying, make sure you stay at home and stay safe. We are in critical moments. We are not in normal times. If you don't have anything doing outside, make sure you stay indoors and make good use of this time. Spend quality time sitting down and studying. Don't waste time on social media, WhatsApping, unnecessary chats and all that. Spend the time, this time, to study. And the questions we are going through, make sure you acquaint yourself well with them. The tutorial questions that have been posted on your platform, WhatsApp platform, make sure you go through them. The various discussions that are going on in your elective subjects, other subjects on the WhatsApp platform, make sure you participate in them actively. Okay, thank you so much. Until we meet again, God richly bless you.